Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson on application of calculus, looking at your classwork on calculus of motion. Now we're gonna attempt and answer calculus of motion. Right, so here's a brief introduction. Calculus of motion is a branch of maths that we use derivatives and integrals, which you don't do in school, to study and describe how objects move, especially how their position, velocity and acceleration change over time. Right, so if we use the letter ST to represent position of object, time t for displacement or position, then the first derivative generally is velocity. So to get velocity from a ST equation, we're going to find the first derivative of position. So velocity of time equal the derivative of s with respect to time. So I differentiate s with respect to time. This tells me how fast the object is moving and in what direction. For acceleration, at, we use the second derivative of position or the first derivative of velocity. So acceleration equal my second derivative of position over the second derivative of time, or tv over dt. Measures how the velocity is changing. And for displacement, to get the change in position over a specific time interval, we take the biggest time minus the smallest time to see how far it's moved. All right. By substituting back in the equation. So calculus of motion, I just need to know. My apologies. We will always give you an equation for position. From that equation, we're going to use the first derivative to find velocity, second derivative to find acceleration. All right. And then we can still test displacement or position by giving you two different times. So we left at time 5 minutes, and at time 10 seconds is calculating how far is moved. You're going to subtract that too. Right, so let's look at the first problem. Distance fallen by a stone which has been dropped from a building is given by st equal 4,9 t squared, where t is the time in seconds and st the distance in meters. So most learners that do physics will know this is a vertical projectile motion problem. Right, now they say determine the average speed at which the stone fell between the second and 6th second. Right, so now we have to substitute first 2 in there and 6. Right, we want the average speed at which the stone is falling. So for speed, first derivative, remember that's position, right? Right, but here using the gradient is also first derivative. I'm going to say the change in y over the change in x. So my change in x is simply 6 minus 2. For the change in y, I have to put 2 and 6 in there to get the y value. Right, so there, S6 minus S2 over 6 minus 2. So that's my 2x values. I want my 2y values. If I substitute 6 squared times 4,9 minus 2 squared times 4,9, right, and that gives me 176,4 minus 19.6. 6 minus 2 gives me 4 divided by 4, and that would give me 39,2 meters per second. That is for velocity. Right, you could have also gone via first derivative. I'm just showing you. I can also use gradient. Gradient and first derivative, basically same concept. So that would be 2 times that would have given me 9,8 t, and my t is 6, and the 2, if I subtract, I would have gotten to the same answer. Right, next problem. Distance fallen by a stone which has been dropped from a building is given by st equal 4,9 t squared, where t is the time in seconds and st is the distance in meters. Determine the velocity of the stone after 2 seconds. So after 2 seconds, for velocity, I'm going to say first derivative, which gives me from st equal 4,9 t squared, gives me 2 times 4,9, 9,8 t. So at 2 seconds, if I put in 2 here, 9,8 times 2 would give me 18 and 1, 19.6. So after 2 seconds, my velocity is 9,6 meters per second. All right. Second question, after 6 seconds. So again, velocity, first derivative, 2 times 4,9 gives me 9,8 t. Right, I'm going to substitute 6 in there. So 6 times 9,8, let's see, 54 and 4,8, 59, now 58,8 meters per second. So if I subtract that 2, I still get to the same answer I got previously. Right, now in exam, if you say determine acceleration of the stone after 2 seconds, now we have to find first and second derivative, right? The stone is falling, so scientifically speaking, those that do physics, stone is falling due to gravity, right? Free fall. So my acceleration should be 9,8. But yeah, let's solve. So first derivative of velocity, 2 times 4,9 gives me 9,8 t. Second derivative, 1 times 9,8 would give me 9,8. That's for acceleration. So second derivative, 9,8 meters per second squared. And you see there is no place to substitute time in, so my acceleration is 9,8. If I said 7 seconds, again, first derivative, that gives me 9,8 t. And my second derivative stays 9,8 meters per second squared. So as you can see, my acceleration due to free fall will always be 9,8 meters per second squared on average, based on my gravity, because it's falling due to gravity. Now the distance fallen by the stone, which has been dropped from a building, is given by ST. Same question. The stone hits the ground after 15 seconds. Determine the height of the building the stone was dropped from. Right, so we know ST equal 4,9 t squared. Right, that's my position. 15 seconds. So S15, 4,9 times 15 squared. Remember, S is for position. 225 times 4,9 gives me 1,102,5 meters. So that is how far the stone has dropped in total. All right. The speed at which the stone hits the ground. So to get speed or velocity, I need the first derivative of that. It takes 15 seconds. So first derivative is going to be 9,8 t. Alright, so if I find first derivative, 2 times 4,9 gives me 9,8 t. And it took it how long? 15 seconds to reach the ground. So in the place of t, I'm going to put 15 times 9,8. Alright, and that there should give me something close to 150. Which is 147 meters per second. You see what I did? I estimated 9,8 is almost 10, so 15 times 10 gives me 150, right? That's how I estimated the answer would be close to 150. It can't be bigger than that, all right? 4.3, we want the acceleration of the stone as it hits the ground. So for acceleration, I need second derivative, right? So first derivative, 2 times 4,9 gives me 9,8 t. And second derivative simply stays 9,8 meters per second squared. So acceleration is still falling due to free fall. All right, so I hope you follow. It's a basic introduction to calculus of motion. I wish you nothing but the best. God bless. Bye.